Hi everybody. So I wanted to go over the question of the day that I gave you today. That was an Mcas question. So let's start by reading it, finding out what we are given, and then using the equation to solve. So use the illustration below that shows a car slowing down to help you solve. So we're given an illustration of a car. We're given the deceleration, which is 4.5 meters per second squared, and the initial velocity 15 meters per second. Sweet. All right, so the car was initially traveling at 15 meters per second. The car slows with a negative acceleration or a deceleration of 4.5 meters per second squared. How long does it take the car to slow to a final velocity of 4 meters per second? All right, so let's write down what we are given. So we can start that we are given with an initial velocity. So we can say that VI is equal to 15 meters per second. And the car slows with a negative acceleration of 4.5 meters per second squared. So we know that, deceleration and acceleration, it's just a negative acceleration. So we can say that's 4.5 meters per second squared. And how long does it take the car to slow to a final velocity of 4 meters per second? And I'm sorry, it's a deceleration, so that's negative. I'm sorry, I didn't put that in there. So a final velocity, so VF, right? That would be 4 meters per second. All right, now let's look at our equation sheet. So let's go show my desktop. All right. So I am given a Massachusetts Comprehensive Assessment System Introductory Physics formula sheet. Okay, this is what you're going to be given as a formula sheet for Mcas. And again, this is posted in your Google Classroom, so make sure you take a look at it and let me know if you don't know what, your linear motion equations. All right, make sure you understand them. The other ones we will get to throughout the year. All right, so we are given average speed, average acceleration, average velocity, and then some kinematic equations here, 1D linear motion, okay? So if we wanted to solve for average acceleration or just acceleration, this is how we would do it. We would find the change in velocity over time. But here's the thing, we are given the acceleration or the deceleration in this case, and we're also given velocity, and we need to find out the time. So we can use this equation in order to solve out the time. Let me show you how to do that. So how long does it take? Well, we need to find the time, which is a question mark to us. So acceleration is equal to the change in velocity over time. Okay, so in order to solve for your time, you need to separate it out. Okay, so what do I mean by that? Well, you need to isolate it. You need to get it alone. Okay, you need to set it equal to something so you can solve. So let's start by doing that. Let's get it out of the denominator. So in order to do that, we multiply both sides by time. Okay, so this cancels out the time here, and we are left with t times your acceleration equals your change in velocity. All right, so I got it to one side, but it's still the acceleration there. So what do I have to do? Well, to isolate it, all I have to do is divide by acceleration on both sides. So that cancels out the acceleration here, and I am left with time is equal to the change in velocity all over the acceleration. Sweet, so I have the equation that I need to use now. So let me just scroll down here, and we can start by plugging in some of our information. So we are given that t is equal to the change in velocity over acceleration. And again, the change in velocity is equal to the final velocity minus the initial velocity all over, in this case, acceleration. All right, so let's go ahead and scroll down again, and we'll plug in some of our information. So our final velocity was 4 meters per second. And our initial velocity was 15 meters per second. and our acceleration was negative 4.5 meters per second squared. So now we just have to do out the math. All right, so doing this out, we get negative 11 up at the top, that's meters per second, and 4.5 meters per second squared. Again, it's negative because it's deceleration, and we get a time of 2.44 repeating seconds. All right, so we'll just call it 2.44 seconds. So what does this mean in terms of our problem? Well, it says, how long does it take the car to slow to a final velocity of 4 meters per second? Well, the answer to that is 2.44 seconds. I hope this helped. If it didn't, please let me know and I can give you another problem and see how you're doing. All right, have a good day, y'all.